Hello, so we're back, and this time we have a proper nice gaming machine here. So this is a Acer Nitro 16. We have Ryzen 7 and NVIDIA RTX 4060. Now let's check the customer email. So what the customer is saying, laptop does not power on when power button pressed, either on wall or just battery, and no charge light when plugged in. No fine noise, lights, or other signs of life. So the customer was using the PowerPoint on the moment the laptop shut down, and it takes no power even if you plug like a USB-C. The customer is suspecting a battery issue or board level component short. I'm assuming the same thing. Probably, the main power is shorted. Anyway, let's have a look. The problem? Pressing the power button, and of course nothing happened. We're not gonna plug the power in, yeah? I will say let's open the laptop and let's have a look inside. So this is a new model of Acer Nitro. So the new generation of Acer Nitro is better compared with the last generation, can be a different fault, or is the same thing like shorted MOSFETs. Not sure, we're gonna find out together. And the back cover is removed. Yeah, it's a totally different board, you can see that. And we have two USB-Cs here. We still have the classic power port. We have the BIOS battery there. Let's unplug the big battery. So the battery is unplugged. Let's check the main power rail. I mean, I don't even know where to check the main power rail. But what I can see here, you see this is a better design. So check here, yeah? What do you think is under the heatsink here? Here. Just say it. What do you think is there? Maybe you can't see the design. Check the design, yeah? You have the charging port. Then what you see there, yeah? You have the second MOSFET, and then you have the current sensor. So the first MOSFET is actually under the heatsink. So they learn. Can't believe. So the main power rail is here. And the main power rail is 134 ohms. This is bad. To have 134 ohms on the main power rail, it is bad. This is a partial short. Or a shorted VRAM or RAM power supply or stuff like that. In order to check, we have to take out the heatsink. Yeah. I will be honest with you, this is the first laptop ever I see actually the first MOSFET under a heatsink. Never seen this before. I mean, even the cooling system, yeah? You have 3 pipes, GPU and CPU, right? Then you have 1 pipe for the GPU power supplies. Yeah, it is an improved design. I was asking, okay, the screen cable is still here, but what they did with the Wi-Fi? Remember on the old model, the Wi-Fi was coming here. But now they are using internal antenna, a Wi-Fi antenna. Yeah. And the heatsink. It's out. Wow, 1 second. We have liquid metal on the CPU, check that. Which of course is not bonded on the middle. Now you can have a better look, and you can see actually the first MOSFET is under the heatsink. Yeah. Fantastic. So what we are checking? The GPU, the VRAMs, yeah, proper nice design. This is a hard fault to be diagnosed. You have a high resistance, main power rail, actually low resistance, but not that low. So even if we are coming with current, probably we will not see anything, and we have to deal with this, with actually not seeing much. So ground. Let me lower the voltage to like 1 volt, yeah? Good. So coming with the... I mean, I'm assuming it's the main power. Let's double check. Oh, yeah. You can see the design. So what do you have? You have one MOSFET, then you have another one, then another one, then another one. Because USB-C, one USB-C is connected here, and one USB-C is connected here. Yeah. That's why they are using more MOSFETs. Yeah, but definitely that's our main oh, and we have a CYPD PD controller. This is bad. When this chip is dying, you can throw it on the bin. You can't program that chip. Or you can, but it's proper hard. So, coming... Actually, let me bring the thermal camera on the screen. No, I take my words back. They didn't learn anything. That PD controller is the worst PD controller you can use on a laptop. From a simple reason, you can't replace it. Yeah. So, thermal camera. We have the thermal camera on the screen. Yeah, we do have ground. Great. So coming with current exactly here. And check there how much current is taking. Like 7 milliamps. No, not sure how we can approach this fault. It's so tricky. But I think I know how. Okay. We cannot spot anything with 1 volt, but we can check the resistance of the main power rail with different coil outputs. So let's see. With the ground, obviously, we have like 137 ohms. But what about with the VRAM? It's higher. Higher means has no connection. 138, yeah, it's like ground here, yeah, here, okay, here, nothing, here, nothing, here, 140, 147, here, no, no, so, no, so the main power rail is not shorted with the output, and this is interesting. No, you can't raise the voltage. I mean, we can, but we have to be sure we are not pushing the current into the CPU or something. I mean, yeah, probably the customer already plugged the charger. Let me try something else, yeah? So what I will try is to come with 1 volt on the main power rail and check the output of the coils. So what do you think about that? Coming with current here and checking the output. But we need volt. And the output, this one is 0, this one is 0, 0, 0, yeah, 0, 0, 0, here you have a coil, 0, here is 0, and here is 0. I will admit that this is a more difficult fault. It's the most challenging fault. Because if we are raising the voltage, I mean, yeah, the charger already was plugged in. Okay, let's do it. Let's do it. So raising the voltage. So it's taking like 40 milliamps. With 40 milliamps, with the thermal camera, we should be able to spot this current. Hard, but we should be able to spot it. Can you spot anything? Off, on. On, off. Nothing. On, off. On, on, off. You mean nothing? Why nothing is getting hot? Okay, let's raise the voltage. Oh, okay, we touched something. So it was like 90, 200 milliamps. Yeah, now we can spot something. 220. And I can't see anything. Here, on, off, on. Wait, what is that? So all GPUs are coming on? The drivers? Yeah. Because when you're using low voltage, bad things can happen. No, I can't see anything. Yeah. This is so tricky. Okay, let me raise the voltage. 200 milliamps. The GPU are still coming on. Let me raise the voltage. Let me lower the current. Good. About 9 volts. It's short. Okay, now it's proper short. Okay, same like before. It's not proper short. 1 second. Like 100 milliamps. 400 milliamps. You don't understand with what you are playing on this, with what I'm playing on this moment, with the life of this laptop. So the laptop can be still good, but playing with the power supply, this is not the charger. Charger is basic, short, it will shut down. This is a power supply which it will push current no matter what. So the current is going up to like 500 milliamps. I still can't see anything. Oh, what is that? Here? Here? No, here. What is that? Where is it? Here. Wait a second, is the MOSFET? Wait. On, off. On, off. Is the MOSFET or the capacitor? On, off. On. You think it's the capacitor? This capacitor grow a beard, you can see. Let me grab the alcohol. Alcohol, great. On, off, on, off. Okay, this is kind of bad. You can see the alcohol moving here. Here, you check that. No, I'm not sure if you can see it. But it's also spinning around the capacitor. Let me check the output of that coil, just to know if it's safe to raise the voltage or not. So the output of the coil is 0.2. No, you know what? Let me raise the voltage. Let me raise the voltage. I believe it's the capacitor. That's what I believe. Higher voltage, but never seen something like that. Check there. So the capacitor actually has a very high resistance. I think it's the capacitor, right? Yeah, it's the capacitor. Check there. It's like smoking. It's not this capacitor. 1 second. I think it's a capacitor under. What is that? What is that? What is that? Just say it. What is that? A shorted pizza, right? Yeah. Can't believe. Can't believe. Dodgy capacitor. And the capacitor is out. And we will have to find exactly the same value and replace the capacitor. Of course, not on this video, but very soon. Fantastic. So what about now? What about now? Now, it's not short. Check that. It's taking no current. It's taking some current, but not that much. Checking the resistance. We have infinite resistance, which is normal to have like infinite resistance. Yeah. Now, let's see if the other things are working. Let's plug, because maybe a MOSFET got shorted. Let's plug the battery and see if it's charging. So the battery is plugged in. We need 19 volts, a lot of current. Plug in the charger. A 130 milliamps. Huh? It's not charging. Because battery is dead. Let's come with the power supply. 19 volts, exactly on the plus of the battery. And the battery is not charging. But it's taking no power, that's the thing. Maybe it's a different design. But it's not charging even with the charger. So why is it not working? Let's check if the main power rail is present. So the main power rail is 19.9. Check that. Why this laptop is not charging? No, nothing. Why the battery is not taking current with the power supply? Let's try to press the power button. Let's see if the laptop is alive. So pressing the power, coming on. Okay, we have no heatsink, but it's coming on. And the battery has charge. Check that. The laptop is on. Oh, let me unplug it. Okay, that's great. The laptop was not charging, and the battery was not taking power from the power supply, but the battery is holding the charge. Just to understand. So the battery not only is good, but it's not locked. Let me bond the liquid metal to the CPU. Okay, so the liquid metal is bonded with the CPU. And here, perfect. Now what we are doing with this? Huh? Yeah, like that, right? So the liquid metal, it will be contained inside. I don't think this is actually PTM pad. I mean, it's getting... No, it's not. Okay, let's replace the thermal paste. No, definitely this is not a PTM pad. Great, we have thermal paste, fresh. Okay, the heatsink is back in place, so plug in the battery. Now we can power on the laptop. It will not overheat. I mean, this is freaking insane. The battery has no screws at all. You can't put screws on the battery. I mean, they start doing the things cheaper and cheaper. I mean, how much it will cost to have like some screws here? I mean, the battery has things, but the laptop doesn't. Insane. Insane design. So pressing the power button, the laptop it is coming on. Let's wait a little bit because we reset the BIOS. We have picture. That's crazy. It's taking so long to start after a BIOS reset. Yeah, and the laptop is starting, I'm assuming. Great. The Windows is loading. Let's see if it's charging. So plug in the charger. And it's taking 3.8. I have a current limit. Okay, that's fine. We're gonna shut down the laptop and see if it's charging. 165 Hz display. Yeah, everything is on. The battery is fully charged. Do you think that can be a reason why this laptop is not charging? So plug in the charger. And it's still not charging. Okay, you know what I will do? It is possible. It's a new model. I mean, doesn't even have to be new. I know all laptops, they have charge to 100%, then start the charge again when the battery is reaching like 80%. So I'm gonna leave the laptop on with the fans and wait for the battery to discharge. Okay, the battery level went down a little bit. Let's try it again. Plug in the charger. 230 milliamps, check there. That's the pre-charge current and 3.3 amps, the charging current. You can see it? Yeah. Not sure where is the charging LED. Yeah, here. Here you can see the charging LED. Yeah. So it is charging, but the current is going down quickly because it's high current and the battery is nearly fully charged. So yeah, it is charging. But one more time, I can't understand, even in 1,000 years, yeah, this is this is not a cheap one, yeah. We are speaking over £1,000 laptop. You can't freaking use screws on the battery. I mean, how much it will cost? This is insane. You can't work with this. Has no screws because you cannot screw the battery. No. So the battery is just sitting here like, it's not about like it's not supposed to be open, but it's an expensive one. How much the screws can cost? You know what I mean? This is crazy. It's just insane. I mean, you decide to save money on screws from the battery. It's just, you know, yeah. Anyway, I'm happy I fixed the customer laptop. It was a lucky customer because usually the things end badly. Shorted capacitor like usual, but the fault was tricky because finding a short which has high resistance, and it's high resistance because you can see it like high resistance. When I know the main power rail has to be infinite resistance, 135 ohms, it's actually low resistance. And when you have like high resistance and you're coming with low voltage, you will see nothing. That's the problem. And the way I'm using the power supply, I know what I'm doing. So when I'm pushing current and I don't know where I'm pushing the current, that's the thing you can't see. You remember we see no current. Then that's a problem. That's the moment when the things can go wrong. So always ask yourself, okay, where my current is going. If it's not going anywhere, then try to do exactly what I did. You come with 1 volt and you check the coils for voltage, in case you have like a partial shorted MOSFET, let's say. Okay, thank you for watching. You know, like, subscribe if you like the video, and also have a look on our Patreon page. See you on the next one. Bye.